Hello everyone, welcome back to the course on cryptography and network security. So my name Dr. Janardana DR, working as an associate professor in the Department of CSC, Nitya Meenakshi Institute of Technology, Bangalore. In today's session, we try to understand how the Advanced Encryption Standard algorithm is going to be provide more secure to the encryption and as well as the decryption, so compared to DES algorithm. In the previous sessions, we discussed about how the simplified DES algorithm works, how the key we are going to be generating in order to perform the encryption and the decryption, and also we have been studied about the 64-bit block data performing the encryption and the decryption in the DES algorithm. That is the entire overview of the DES architecture, and also we have discussed about the various advantages and the limitations. And in today's session, we try to understand how the limitations of DES is going to be overcome in AES algorithm. In today's session, we try to understand the introduction to AES algorithm and why it is essential AES algorithm compared to DES algorithm. Then we try to understand this overall structure of the AES algorithm and the various rounds of transformations which is involved in every round, and the final round of the operation. So then we have to understand the key expansion. So how we are going to be generating the key for every round, the practical example, and the applications of AES. So when it comes to the learning objectives, by the end of this session, the learners will be able to understand the working of AES algorithm. So they will be able to explain the structure of the AES and the various rounds involved, and able to describe each transformation in AES, and also they will be able to understand how AES keys are generated, and also at the end they will be able to apply the AES algorithm in order to perform encryption process step by step. So come to the introduction to AES algorithm. So AES stands for Advanced Encryption Standard. So it has been published by NIST in the year 2001. So it has three different keys. So 128-bit key, 192-bit, 256-bit keys, and with 128-bit data. So each round consists of 4 separate functions. So the very first function we called as, or function or the transformation called byte substitution. So permutation, the arithmetic operations over a finite field. So XOR with the key. The final round contains only the tree transformation. So these are the various functions that has been involved in every rounds. So and mainly we are going to be using this AES algorithm. So in order to provide the secure communication, so and also in the case of banking transactions and the data which we are going to be encrypt and keep it in the storage. So why AES is required over DES? So DES, the main limitations what we have been seeing is the smaller the key size. So because of 56-bit key, so it can easily breakable, and the AES is going to be supporting 128-bit of the larger key, and the three sets of the key sizes, one is 128-bit, the other one is 192-bit, the third one is 256-bit keys. So and it is also going to be performing more faster and more secure way, and also it is going to be resistant to brute force attacks. So when it comes to the structure of the AES algorithm, the plain text block size is of 128 bits. It is fixed. The only thing is we will be going to make use of various keys in order to encrypt the 128-bit block. So the data which is available in 128-bit, which we are going to be representing in the 4x4 matrix. So that is nothing but 16 bytes. So in every cell of the matrix is going to be having 1 byte of value. So 4x4, 16 byte, that we called as a state matrix. When it comes to the number of rounds, so when we are going to be choosing 128-bit key, then it involves 10 rounds of operation. If I choose 192-bit key, then I will be go with respect to 12 rounds of operation, and when it comes to 256-bit key, so it is going to be perform 14 rounds of operation. So the AES is mainly based on the substitution permutation network. So here is the entire overview of the AES structure. So you can see at the very first step at the top, so I'll be going representing the 16 bytes, that is 128 bits of plain text block. So that I will be going converting into the input state that we call as a 4x4 matrix. Then it will be gone performing the initial transformation, the very first step of operation. So when we have a 4x4 matrix of input block, we'll be gone performing the XOR operation. So I'll be gone make use of the round 0. I'm going to be called this stage is round 0. The key will be 16 bytes. So whatever the key 128 bit, that is 16 bytes, we are going to be using that same 16 bytes of key. Again, we are going to be representing in terms of 4x4. So that 4x4 we are going to be used to perform the initial transformation. We just go on performing the XOR operation at the very first stage. So once we're done with initial transformation, so that output of that we are going to be called as a state matrix after the initial transformation. So that will become an input to the very first round. So every round will be go on having 4 transformation. So at last round we'll be go on having the 3 transformations. So we'll look into what are the various transformations in every round. So the very first transformation which we're going to be performing is substitution. So we are going to be performing that substitution operation. So then we'll be go with respect to, see, in the similar way we will be go on expanding the key. So whatever the 16 bytes of key we have, 128-bit key, we'll be go on expanding that. So for every round I'll be go on producing 16 bytes of key, so that will be given. So at the last transformation, that is nothing but AddRoundKey operation. So after that, whatever the output we are going to be get, that will become an output state for the next round. As an input it is going to be working. So likewise, so at every round it will be going to perform the 4 transformation. Only at the last case we are not going to be performing the 4 transformations and all. Substitution byte, shifting rows, mix column, add round. So these are the 4 transformations which is going to be get involved in every round other than the last round. So in the last round we are not going to be performing the mix column operation. So only the substitution will be there, shifting row will be there, and add round key. So there will be no mix column transformations in the last round of the AES algorithm. So each round of consisting of substitution bytes. So we are going to be replacing the every cell value with a substitution box. So we are going to be having 16 cross 16 substitution box. So whatever the value which we have in the case of 4x4 matrix, every cell value will be get replaced by choosing the S box value, the corresponding S box value. So this is we are going to be called as a non-linear transformation. Then after performing all the 16 bytes value converted into an S box value, then we moving on to the next transformation, that is we are going to be called as shifting rows. So rows are shifted cyclically and it is going to be provides diffusion. So the very first row element in the 4x4 matrix we keep it as it is. The second row elements shifting towards left side, circular shifting towards left side by 1 byte. So then the third row is going to be shifting towards left side by 2 bytes, and the third row is going to be shifting towards left side by 3 bytes. So this is how the shifting, the row operation is going to be performing. Then after that, so we'll be gone performing the mix column. So columns mixed with the matrix multiplication. So it is going to be work in GF of 2 to the power of 8, and the last round will be add round key. So whatever the key which we have been generating for every round, so that key we are going to be used to perform the XOR operation with the output of the mix column. So these are the 4 transformations has been involved in every rounds of AES algorithm except the last round. So here is the one we can able to see how the AES round structure has been involved. See the plain text. I'll be gone performing the very first initial transformation. So that is nothing but add round key that we called as round 0. Then so round 1 gets starts. So substitute bytes. We just go on replacing every cell value with the substitution box values. Then afterwards we have to be shift the rows towards left side cyclically by 1 byte, 2 byte and 3 byte. Then third transformation will become the mix column and the fourth one will be add round key. So likewise it will be go on continuous till it reaches the last round. The last round will be gone performing only the 3 transformation. So when it comes to the other side, so this is the encryption side. Plain text is get converted into ciphertext, and the other side decryption. So ciphertext will has to get converted into plain text. See here in the round 1, it contains the 4 transformations. That is, we are going to be called as add round key will be there, inverse shifting row, inverse the substitution byte, add round key, and the inverse mix column. So whatever we have done from plain text to ciphertext, that in the reverse order we have to be gone perform from ciphertext to plain text. And at the last round we'll be gone having again the 3 transformations only, that is inverse shift row, inverse substitution bytes, and add round key. So this is how we'll be gone converting one block of plain text to cipher and cipher to plain text. So final round substitution, shift row and add round. So there will be no mix column in the final round because it is going to reduce the complexity while maintaining the security. So now we try to understand about how the AES key generation. So because in the right side what we have been seeing, so round 0 will be having 16 bytes, in the round 1 we will be having another 16 byte. Likewise, how many rounds will be there? Those many bytes of key we are going to be generating from the original key. So how we are going to be expanding this? So here the original key converts into multiple round keys. So AES is going to be comes with 128 bit. So if it is 128 bit key, then we have to be going generate 11 round keys. So each round uses the unique key. So the steps involved in the case of key expansion process. So divide the key into words, that is 4 bytes each. So applying the transformations, so rotating the word, substituting the word, and round constant. So it is going to be generate the new words by using the XOR operation. See here in the diagram you can able to understand we are reading row wise while writing the column wise. So whatever the 16 bytes of values will be there, that I'm going to be representing into a 4x4 matrix, that too column by column. So K0, K1, K2, K3, the first 4 bytes, the next 4 bytes, third row, that is third column 4 bytes, and the fourth column will be the another 4 bytes. So this is how we'll be gone representing the 4x4 matrix of the key values. So those 4 bytes will become an one word, that is W0. The next 4 bytes will be working as a W1, the next will be W2, and the next will be W3. So in order to generate the next round, so I wanted to generate for the W4, W5, W6, and the W7. So we are going to be giving the last word, the W3 is passing into the function G. So the output of the G is giving as an input to the XOR function. See here, whatever the output of the G function is there, that I'm going to be giving as a input to the XOR function, so which is going to be taking another input from the word 0. So these two performs the XOR and it produces the W4. Next, so when I wanted to generate W5, so W4 value is becomes one more input to the next level of XOR function with W1 value. So these two, W4 and W1 value, will be able to generate W5. Similarly, W5 and W2 will be able to generate W6. W6 and W3 value will be able to generate W7. So when going to next level, that is W8, W9, W10 and W11, so this W7 value is giving as an input to G function once again. So the output of the G function is going as an input to the W8, and W8 will be get generated so with respect to W4 and as well as the G function. So likewise, this process will be go on perform till it reaches the W44 values. So from W0 to W43 values will be able to generate it. So now we try to understand how this G function. So it is going to be giving the output value for the next round. See, assume that W3. So those 4 bytes are B0, B1, B2, B3. I'll be go on performing the rotations and all. So I'm just go on shifting towards left side by 1 byte. So it becomes B1, B2, B3, B0. So now I'll be go on make use the substitution box to replace the value which is available in B1, B2, B3 and B0, making use of substitution box. The new values will be B1 dash, B2 dash, B3 dash and B0 dash. With these 4 values and the one more value called round constant. So the round constant, so the MSB value of the round constant will be having the specific value. The rest 3 bytes of values will be by default 0. So these 4 bytes of value and these 4 byte B1, B2, B3, B0 is performs the XOR operation, and that is going to be provides a new value, that is output of the G function. So this new value W dash is giving as an input to the next XOR function to generate the next word value. So this is how the key expansion algorithm is going to be performs. So what are the various transformations we have seen? So first, the rotation. So rotation of the word, substitution the word and the round constant, and then we have to be gone make use XOR function to generate the new word, that is called as G function. So rotation word performs 1 byte circular left shift on a word. This means B0 to B3 becomes B1 to B1, B2, B3, B0. Then we have to be going to perform the substitution, performs the byte substitution on each byte of its input word using the X box. Then the result of step 1 and step 2 is XORed with a round constant value. So the round constant, so how we are going to be calculating it? So round constant is a word in which the 3 rightmost bytes are always 0. The round constant is different for each round, and it is defined as the round constant of j equals round constant of j comma 0 comma 0 comma 0. So that with round constant of 1 equals 1, then round constant of j equals 2 into round constant of j minus 1. So with this equation, we will be able to generate the remaining 9 round constant values. So that is, if I want to be calculate the round 3 constant value, so RC of 3 equals 2 into RC of 3 minus 1. So round constant of 2 is 2, 2 cross 2 will become 4 for the j value 3. So the round constant of 3 will become 4. Similarly, round constant for 4 is 8, for 5 10, 6 20, 7 40. So 80, 9, 1b and 10 will be 36. So these values will be in terms of hexadecimal values. So now in this case, we try to understand how we will be able to generating. So suppose the round key for round 8 is, so this is the key are there. If I divide, so 4 bytes each, it becomes one word. So EA D2 7321 will become one word, B5 8D BA D2 will become the other word, the next 4 will be another word, and the last 4 will be another word. So now the 7F, 8D, 29 and 2F we are giving as an input to the G function. So I wanted to calculate for the round 9. So now I wanted to calculate the words for the round 9. So what will the value? So the ninth value will become 36. So temporary, I'll be going having this word function values, the 4 bytes, the rightmost 4 bytes I'm going to be considered as a temporary value. So I need to be going perform the rotation, that is left side 1 byte we have to be rotated. Then we are going to be able to get 8D, 29, 2F, 7F. Then after substituting these values with the substitution box, I'll be able to convert that into 5D, A5, PAN5, D2. Then the round constant value, that is 9, is 1B. The rest of 3 bytes will be 00. Now I'll be go on performing the XOR operation. So after the substitution word, whatever the value is there, that with round constant value, we have to perform the XOR operation. So once we're done with respect to that, so I'll be able to get Wi minus 4. So the I value is 36 minus 4 means 32. So that is the very first word EAD27321. We are going to be make use and perform the XOR operation. So I'll be able to get the first value for the next round. Similarly, if you go and perform, so I'll be able to get the next 4 words for the round 9. So now we're trying to understand the applications of AES algorithm and what are the various advantages are there and also the limitations. So when it comes to the applications, AES algorithm we are going to be used in the case of SSL or TLS encryption, secure socket layer and transport layer security encryption, and also we are going to be use this algorithm in the Wi-Fi security, that is WPA2 and as well as 3. So we are going to be using in the banking sector, cloud storage encryption, mobile apps security. So various applications we can able to apply it. So when it comes to the advantage, the strong security compared to DES algorithm, efficient in software and hardware implementation. So it is widely accepted standard and resistant to known attacks. And when it comes to the limitations, it requires secure key management. So vulnerable if the key is exposed and slightly complex in terms of implementation compared to DES1. So at this point, we are going to be concluding of today's session. So AES is a secure symmetric encryption standard algorithm, works on the substitution and the permutation network principle, and it is going to be using multiple rounds for the security with respect to the various 3 types of keys, and also the key expansion is critical for encryption strength. So with this note, we are going to be ending this session. So we'll be come back once again with solving an AES algorithm problem in the next session. Thank you.